So earlier in this class, we've talked about corresponding parts of congruent triangles in particular, but congruent figures will be congruent. But corresponding parts of similar figures, they're not going to be congruent because the figures aren't congruent, but they will have a ratio or a proportion. They will have a relationship. So if figures are similar, the side lengths are proportional, and their angle measurements are equal. So if the parts we're talking about are their angles, then corresponding angles will be congruent, but their side lengths are proportional. So here we'll look at these figures. Are the corresponding angles congruent? Well, we got a 90-degree angle. Yep, 90 degree. Yes. You could measure those two if you want, but it looks like it. So if you measure those, that's 90 degrees. We said angle K was 90. D was 90. N was 90. You could measure M and L. You'll find out that they are around like 120 and 60. Rounding a little bit of a guess. You could pull out your protractor and actually measure it. It's no big deal. So if you get your protractor on there, you see M is about, well, it's probably about 115, not 120. But so you can also check the ratios of their side lengths. If they have the same ratio, that means that they are proportional. So you check their corresponding side lengths. So for NK, we can just measure it in terms of the units here. That's 6. And then AD is corresponding to that. That's 3. AB, you can count that out. That's 1, 2, 3.5. KL, 7. For the other side, you could do distance formula if you want to. That'd be a good way to go about it. So BC, kind of tough with the fraction there. It's 1.5 if you turn that into a triangle. That's 1.5. That's 3. So when you do Pythagorean theorem there to get the distance, 1.5 squared is 2.25 plus 3 squared, that's 9. So add that together, you get BC is about the square root of 11.25, which is about 3.35. And then LM, you do the same thing. It's got a length of 3 there, and it goes up 6. So 3 squared plus 6 squared, that's 45. So square root of 45. That's 6.7. You do a similar thing with CD and MN to get the, oh, those are flat. So CD is 2, MN is 4. That's pretty easy also. So we know all the sides here. If you simplify those fractions, you get 1 over 2, 1 over 2, 1 over 2, 1 over 2. So the ratios are all equal. They have a common ratio, and all the angles are the same. That means they are similar. Or they are, and therefore they're proportional. If you look at these two rectangles, it's got a length, this side has a length of 3, this side has a length of 5. So that ratio would have to be the same as the ratio of the other sides, which is 4 to 7. Does 3 over 5 equal the same thing as 4 over 7? So to check if two ratios are equal, you can cross multiply. You multiply the 3 times the 7, you get 21, and you multiply the 4 times the 5, you get 20. Those are different numbers, so they're not equal. So they're not going to be congruent, but the angles, the corresponding angles, are congruent. So I got a little bit ahead. I put some of the wrong ratios here. AB is 4, EF was 7, BC was 3, FG was 5, CD is 4, GH is 7, and then AD is 3, BH is 5. So this about the side length ratios, that tells us they're not the same, so they are not similar figures. So all rectangles are not similar. Even though they have the same angles, they don't have the same ratios. Here you can tell pretty easy just by looking at it. We don't need to go through the measurements. We can see that angle P is much, much smaller than angle W. We don't have to measure them because we know, we can see it's way small. We can take some of the side lengths though. PQ has a length of 3, WX has a length of 6, RS also 3, and YZ is also 6. If you wanted these, the lengths of PS and QR, you could do Pythagorean theorem, so that's 1 and 2, so that's the square root of 5. QR is the same thing, you can see it over here. Oh, the picture is going in 2 increments of 2, so actually this is all doubled, doesn't really matter. So when it went 3 spaces, it's actually a 6 over 12. The ratios are the same though. And these lengths, it goes up, actually goes up 2 and over 4, because we're counting by 2s. So that's 16 plus 4 is 20, so it's square root of 20 instead. Do the same thing for XY. This has, since we're counting by 2s, a length of 2, and 2, 4, 6, 8. So 64 plus 4 is 68. You can reduce this to be 1 over 2 and 1 over 2. If you type these into your calculator, you do not get the same ratio. The square root of 20 divided by the square root of 68 is not 1/2. So they have different ratios. So if two figures can be mapped onto each other with similarity transformations like we did in the last unit, we could do translations, reflections, rotations, and dilations. So if they are similar, they have these properties. The corresponding angles are congruent, corresponding sides are proportional. So here we have two similar triangles. We're told they're similar. That means that their angles are congruent, A and X, B and Y, C and Z. And the side lengths are proportional. So if you take AB over XY, that's the same fraction, the same ratio as BC over YZ and AC over XZ. Just the corresponding sides would be proportional. So if EFGH is similar, it maps onto RSTU by similarity transformation. You can write a proportion that contains EF and RU. So since we're trying to use EF and RU, you don't even need to draw them out. You just have to look for how the letters are written in the order in the problem. So EF corresponds with, since it's the first two letters, it corresponds with the first two letters, RS. And that will be the same ratio as, we got to take the same two letters. We want R and U this time. We're taking that from the second figure that goes on the bottom, just like before. And then since we did first letter with last letter, we're going to take the first letter E with the last letter H. As long as you take the letters in corresponding order, it'll match up. And if we're going congruent to angle G, since G is the third letter, that will be congruent to the angle T because T is the third letter. Angle U is the fourth letter, so that's going to be congruent to angle H, which is also the fourth letter. So here we have the same thing going on. We have TX in the bottom, so that's the first and the last letter. That will go with JN up top, first and last letter. Then we have LM, which is the third and fourth letters. I take that with VW, the third and fourth letters. Angle V, that's the third letter, so that'll be congruent to angle L, which is also the third letter. And then angle K, which is the second letter, will be congruent to angle U, which is also the second letter. So here we have two similar triangles, and it gives us the side lengths. QR, the second and third letter, with MN, the second and third letter, so those must be proportional. 6 over 9. We take the QR over MN. Now, since we're trying to map PQR onto LMN, We actually want this the other way around because LMN is where we're ending at. That's what we start with at the top of our fraction. So we're actually going to flip this around, have that be 9/6. That's our scale factor. We can reduce that to 3/2. That is our scale factor. So when you write the transformation, it is a dilation with this scale factor. So coordinate notation, we take x, y. 3/2 is our scale factor. And that's the coordinate notation. You just need to remember that the ending figure is the one that goes up top. LMN is where we're ending, so that goes up top. And 9 goes on top. So if triangles DEF and UVW are similar, then DE, first two letters, over UV, the first two letters, good, equals VW, second and third, over second and third. So the positioning of the letters is correct, but what's wrong is they put triangle DEF first on the first equation, and then in the second equation, they put the other triangle first. You always have to put the same triangle up on top. So this needed to be flipped around because triangle DEF needs to be on top every time. Triangle DEF needs to be in the numerator every time. You can't switch the triangles around halfway through. So now we're going to use these ratios that we've been setting up and talking about to find values of x and y. So we can write proportions because these have to be similar figures. The main thing is you always take the same figure in the numerator in both parts of the proportion that you're writing. So we could take 4y. If we write that first, that corresponds with the side length that's 10. Then we can take the 3y minus 5, same figure in the numerator each time. That corresponds with 5. So we have an equation, we have a proportion, we can cross multiply and solve this. So 5 times 4y is 20y. And then 10, we're going to distribute that here. 10 times 3y is 30y. 10 times negative 5 is negative 50. And we'll finish solving it. So get your y's together. That's negative 10y equals negative 50. So y equals 5. Side lengths are proportional, so you write your proportion, you solve it. Then for the 95-degree angle, that's corresponding over here to the 4x plus 27 degrees. Corresponding angles are congruent, so they're equal. You write your equation and solve it. So you subtract the 27, you get 68, and then divide by 4, you get x equals 17. So same idea here, we need to write the proportion. These two angles do match up. They're corresponding. If you rotate this around, you can see it. So that means 4x equals 5x minus 5. Solve that equation for x. So we distribute Subtract the 5x over, you get negative x equals negative 25, so x equals positive 25. And then we can take our side lengths to write a proportion. So we can take the 2y minus 8. That's going to be corresponding to this side over here, the 4. And then same figure first, so the one on the left, the 1.5, will be corresponding with the 1 centimeter. So we can cross multiply, so 1 times 2y minus 8 equals 4 times 1.5, which is 6. Add the 8, you get 14 equals 2y, so y equals 7. X equals 25, y equals 7. So here we're told triangle ABE is similar to ACD. We can find the value of x because those angles are corresponding, and therefore they are equal. Back to 14, you get 36, divide by 3, so you get x equals 12. Now when we're trying to solve for y, this gets a little bit tricky because we're taking if we take the smaller triangle first, the 5.6, that corresponds with this side AD. The y centimeters is only this little portion of it. So the entire length of AD, that entire length is 5.6 plus y. You have to add the two segments together. And then we did small triangle first, so we're going to do the small triangle first this time, 4 centimeters over the big triangle. We don't need to add anything this time because it's only the one segment. DC, the entire length there is 5. So we have our proportion. We just have to cross multiply and solve now. So 5 times 5.6 is 28 equals 4 times 5.6 plus y. You have to distribute that. Four times 5.6 is 22.4. So we'll subtract the 22.4 from the 28. 5.6 equals 4y. So divide by 4, you get y equals 1.4.